Hello, everyone. Welcome to our webinar. My name is Anna, and I'm excited that you're all here. So today's webinar topic is Fast, Secure, Resilient, Modernizing Application Security at Scale. Today, our webinar is presented by WallArm and hosted by SecurityBuzz. So first things first, feel free to ask questions throughout this webinar. Utilize the Ask a Question feature in the webinar console. We will collect and address all questions at the end of the presentation. If we don't get to your question live, don't worry, somebody from the WallArm team will follow up after the webinar has concluded. Additionally, we have a $200 Amazon e-gift card for one lucky winner. Stick around until the end of the presentation to see if you've won. We will be announcing it live, again at the end of this presentation. Finally, you can find fresh content related to today's webinar topic in the Related Resources section of your webinar console. With that, I'm going to turn it over to Celeste Kinswood of WallArm, and she'll take you through the presentation. Thanks again. Celeste, over to you.
And thank you for joining us for this WallArm webinar on the OWASP Business Logic Abuse Top 10. My name is Celeste Kinswood. I am the Director of Product Marketing here at WallArm. And as mentioned in the title today, I want to talk a little bit about business logic abuse and specifically the OWASP Top 10. For anyone who's not already familiar with the organization, OWASP stands for the Open Worldwide Application Security Project. And that's a global nonprofit foundation that's dedicated to improving software security by providing open source tools, but also documentations and standards. They are, I think, most known for their top 10 lists, of which there are many. But today we're going to dive into specifically business logic abuse. Just walk through the agenda real quick here. We're going to start out by talking about what do we mean when we say business logic abuse, and then hopefully convincing you that it's a problem that you should care about. We'll walk through some of the actual business logic abuse top 10 from OWASP with some examples from real world attacks, and then touch briefly on the end about how you can take action to help prevent the issues associated with business logic abuse in your organization. A quick housekeeping note, if you do have any questions at any point during this webinar, please feel free to put those into the Q&A box at the bottom of your screen. We will try to get through as many of those live on the call as we can. And for anyone who we're unable to address live, we will definitely follow up with you following the webinar. With that, I'll give a big thanks to CyberEdge for hosting us here and dive right into the content. When we talk about a business logic attack, we are talking about an attack that is focused on the underlying logic that dictates how software is used and operated. And I think it's really important that we separate that out from flaws in coding, right? So when we think about a lot of cybersecurity attacks, a lot of what we see in the news, Cloudflare outages with memory issues or major attacks that involve SQL injection. The root cause of these is an actual flaw or error in the code. Usually introduced, by accident, though occasionally introduced by a malicious insider, a developer who is specifically leaving a backdoor for themselves or another attacker later. But these are, again, attacks that are based on flaws in the actual code of the software. When we talk about business logic, we are talking about applications that are functioning as they are designed, but due to a flaw in the logic dictating how they are used, that application is then open to abuse, open to being used in a way that was not intended. An easy example of this one would be, let's say we have an API, and the way the API works is it's supposed to receive coupon codes and give back discounts. If functioning as intended, it receives a code, gives the discount, but there might be a logic flaw that doesn't limit the number of times that coupon code can be used. So then an attacker can abuse that logical flaw to redeem that one-time coupon code over and over and over again. So again, The API is functioning as intended. It is processing coupon codes, or functioning as designed, but it is not functioning as intended. It is producing multiple instances, responding to multiple instances. Other examples we might see might include skipping steps in some sort of multi-factor authentication flow, exploiting an expired session token, a token that really shouldn't be able to give you authorization, but due to a flaw in the business logic, the API is going to accept that token even if it's expired. Or perhaps bypassing rate limits to drain resources. So here, the root cause is missing or flawed enforcement of the business rules that dictate how that software operates. Another way that we divide attacks when we're thinking about them, not just in API and BLA attacks, but really across cybersecurity generally, is the stateless versus stateful designation. So a stateless attack is one where there is a single request made and a single response given, and that's the whole attack. So the example given here is a SQL injection attack. A stateful attack is one where there are multiple connected requests that are building on the context from previous requests. So, enumeration or iteration attacks can fall into this category. Here we see an attacker who is iterating and trying different IDs. So they're trying ID numbers and they're keeping that information that, ID 1000 was invalid, we got a 404. 101 was invalid, we got a 404. But 102 gave us the page. So now we have this understanding of which of these IDs are valid, and we're going to carry that information forward in the attack. One of the reasons I think it's so important to make this differentiation is because of the differences in the ways that these are detected and blocked. So with the stateful attack, and if we can see that there's something inherently wrong with the request, there's a malformed request or a SQL injection, that can be detected in a single response. But when we look at a stateful attack, this is often a more, more advanced type of attack. Each of those individual requests might look legitimate. These are all just ID requests. But when we can look across and see the context that, oh, we're just trying enumeration of all of the possible IDs, it becomes much more obvious that this is likely, requests that are being made with malicious intent. Now that we've talked a little bit about the attack types and what we mean by business logic abuse or business logic attacks, I want to talk a little bit more about the landscape that these attacks are occurring in. One of the first things, and hopefully this won't come as a surprise to anybody on the call, organizations are increasingly viewing APIs as really critical to how they do business, how they build tools, how they do development. Postman, which is one of the leading API platforms, they provide tools for designing, building, testing, and documenting and managing APIs. They ran a survey and asked folks, do you view yourself as an API first organization? And a quarter of those that were surveyed actually said, yes, we are fully API first. Over 50% said, yeah, we are API first. It's not everything that we're doing, but it's really deeply involved. And so together, that's, over 80% of organizations that say, yes, API, we are API first. APIs are critical to how we code, how we do business. I think this is really important to note in this context because APIs are often the most direct path that an attacker can take to get access to those kinds of underlying business logic issues that we're discussing throughout this presentation. This, may introduce for many of you the question, well, okay, how common are these business logic type attacks? So this comes from our own Wallarm Threat Stats report, our most recent version from Q3 of 25. And in that report, we saw that fully 40%, very close to 40% of the API attacks that we saw were business logic abuse attacks. So these are already a very big piece of the pie. But I think it's even more important to note that it is a rapidly growing piece of the pie. So when we look at that same report, we were looking at the quarter over quarter growth for API vulnerabilities and for business logic incidents. And we saw that 20% growth when it came to APIs, but a 30% growth when it came to business logic abuse. So we know that this is not only just a big piece of what's going on, but it's a very rapidly growing piece of the attack landscape. I'm going to shift gears here and dive into the OWASP Top 10 universe. Just a quick reminder that I did see a couple questions come in. So if you do have questions, please feel free to put those in the Q&A. We'll open up for Q&A at the end and get to some of those. But in the meantime, let's take a look at the OWASP Top 10. So what you can see on this slide is that there are many different top 10 lists. For drone security, for cloud native AppSec. But we're going to be here on Planet BLA talking about business logic abuse. And I'd like to talk about why we're focusing in here in this giant world of so many different opportunities. Why are we focused on business logic right now? We might see some limited coverage of business logic out, maybe out in the media as we're covering cybersecurity. It's only one of these top 10 lists. But as we saw in the charts up above, this is an attack type that's really increasing in the real world. Additionally, this business logic piece is an underlying layer. Technologies change, types of APIs change, whether it's, RESTful or SOAP, all of the different, ways that we use APIs might change. But that idea that there's going to be business logic that helps to determine how those are used is persistent across this changing technological landscape. So it's a problem that is growing and it's a problem that's here to stay. Finally, everybody is talking about agentic AI, generative AI. And realistically, those apps are just collections of business logic. So I think we're going to continue to see an exponential bloom of these types of attacks as we move forward. That's why it's time to not only focus developers on business logic issues to ensure that tools are created in a way that avoids business logic flaws, but also to focus our security teams in on identifying and solving those kinds of issues when they do arise. Without further ado, we'll get into the business logic top 10 from OWASP. And I want to talk a little bit to start about the methodology that was used to create this top 10 list. There's four things that I think are important here. First is that OWASP is really great in that they are grounded very directly in theory and strong learning and science to create these lists. They use Turing machine model to guarantee that they're casting a really wide net and understanding all of the different types of flaws that could really be represented. But they're also grounded. It's not an ivory tower. They're really grounding this in real world data. So they're validating this against lists of known common vulnerabilities and exposures, against open GitHub issues, to ensure that this isn't just an academic abstraction. This is really grounded in what developers and security practitioners see out in the wild. I think the other thing that's important here is that this is really focused. Each of these top 10 categories is really a deep dive into that specific area. This is really just about business logic abuse. And so we're not going to see a lot of overlap with those other top 10 lists. Finally, I think it's really cool that this has been iterated. So this taxonomy wasn't just defined. We said, oh, well, we created a list. That's the top 10 that are most important, and never looked at it again. OWASP tested this, plastered it, retested it, and really fine-tuned to make sure that there was precision in the way that these attacks were described, but also a really broad coverage for the types of attacks that are out there in the world today. This is a lot of information on one slide. This is available if you just type in OWASP BLA top 10, you'll get this list. I'm not going to go through every single one of these. We would be here for much longer than the half hour that we have together. But I do want to walk through a couple examples with some concrete real world versions of how this is happening so that we can see the impact that it's having on businesses today. The first one that we're going to talk about here is this missing transition validation, or MTV. Not as cool as the MTV that you maybe watched in the 80s, but definitely very interesting nonetheless. So this is This is calling to a later workflow step because an app is not correctly rechecking earlier requirements. For each of these examples, we'll take a look at how it should function if the business logic was written correctly, and what are some common flaws that might be exploited by attackers. So this is an e-commerce example. We have, a customer who shows up on the site, they view a product, add it to their cart, hit that checkout button, enter their payment details, and finally submit and get that product shipped directly to their house. In normal flows, it's only really possible to add objects to the cart if you found them on the website. But a business logic flaw that we've seen is if the add to cart functionality, if that API only requires a product ID, doesn't require that you actually go through the view product step, attackers can then use one of those enumeration attacks to go through and say, all right, I know some existing product IDs from the website. I'm just going to keep building and iterating and seeing if I can hit unpublished products. An example that we might think of here would be like Nike shoes is going to do a big exclusive drop. They're, having a collaboration with celebrity, and there's going to be a limited number of these shoes. If somebody was able to use that kind of stateful attack to understand, and find that product and add it to their cart before it's even been published on the website, they can then go through the remaining steps, have early access to those shoes, buy out some of that limited inventory, and make a lot of money on the back end. Another example that we might see a little more direct here is just if the actual submit to ship product part of the API does not actually check that you have a valid authorized token for payment. It just checks that you have a valid authorized token for checkout. We can just go past, it's missing this transition validation step, and we can just check out for free and get product shipped straight for free. I've given a couple e-commerce examples here, but I also want to touch base on how this can play out in big enterprise settings. Late last year, a security researcher group uncovered a pretty long list of issues with Restaurant Brands International, specifically their fast food chain drive-through operations, the software that helps run their drive-throughs, across the folks that you're seeing up above. And the very first issue that they looked at was this missing transition validation. In this instance, it was that anyone could sign up to have an account in this software. You didn't actually have to be a franchise owner. You could just register. Now, as you can imagine, being, an attacker who can now register to get access to this software as if they are a valid internal user, can then get all kinds of access to things they should not have internally, including customer data, company data, etc. So these can, be as simple as buying a pair of Nikes that they shouldn't have been able to buy. That is just an example, by the way. I do not believe that Nike has had that experience. I should definitely clarify. But it could be, buying any product online that you shouldn't be able to buy. Or it could be as big as getting access to internal software systems for, a large international food brand. The next one that we're going to look at here is artifact lifetime exploitation, or ALE. So this is where something that should be short-lived, a token, a temporary file, should be expired, but due to business logic issues, it doesn't actually get retired. So if we look at the way this should be used, we see that someone internally, to an org, goes and gets an authentication token from their auth server and uses that to make a call to their API. A matter of moments later, that token should expire, and if they try to make another API call, they should have to go back to the auth server to get another token. When the system breaks, if that token doesn't actually expire, if an attacker is able to steal that token, even though it should have been expired, they're then able to make an unlimited number of API calls because they're authorized. A very real example of this that we saw last year was that in SalesLoft, an attacker was able to get stolen OAuth tokens. To do that, they used a Drift integration, which is an AI chat agent that's connected to Salesforce and other tools. But what they did with those tokens is they were able to systematically exfiltrate a large amount of sensitive data from a huge number of Salesforce customer instances. And this wasn't just PII, which is problematic enough from a security and compliance perspective. This was really high value data, like AWS access keys, Snowflake token, passwords, contacts and opportunities. So this was really high value data that they were able to get because they were able to steal tokens that should have been expired and weren't. Finally, we'll look at SFA or shadow function abuse. So this is where an attacker gets access to a forgotten or a hidden function, maybe something that was set up to do testing internally, and then was accidentally left available when that API was left available when the tool was pushed to production. So they're able to use that to get access to data they shouldn't have. Again, let's take a concrete example. Let's say that internally we have folks inside an org who need to be able to get user data, and so we have an internal API set up for them. And it was originally intended to be internal. There's no authentication, no authorization. This isn't best zero trust practices, right? But it is something that we see out there. And so internal clients are getting access to user data. Maybe somebody on the security team wises up and says, "Ooh, that's not very zero trust of us." Even if it's internal, we should be making sure that we are getting authentication, authorization from our folks who need access to this user data. So they publish a new version of the API. We've got Get User Data V2 that now requires authentication authorization. But somebody forgot to fully sunset, fully deprecate this original API version, and nobody was using it anymore. So we let it go. We don't think about it. Eventually, we push whatever software we're building live to production, and this is still somewhere in the background. An attacker is able to find it. They can then, without any authentication or authorization, get very direct access to user data. Obviously, it's a very serious problem. Um, to look at just how serious, we'll take the Stripe example. One of the things that attackers do often is gain large lists of credit card data. That can happen a couple ways. In this example, they were doing a skimming campaign. So they're actually injecting a fake checkout page into PrestaShop and other e-commerce sites, and they were scraping credit card data that way. Other attackers might just buy that information on the dark web. But either way, you have this really long list of credit card info. But it's difficult to say which of those credit cards are actually still good. So difficult for our attackers to go on a shopping spree. However, in August of going on for a long period of time, from 2 years ago, they were able to exploit a deprecated Stripe API that had originally been used to validate credit card data for Stripe. So Stripe has every reason. This is application functioning as intended. Stripe has every reason to need to validate credit card data. Unfortunately, that API was again made publicly available. Attackers were able to find it, and then they were able to use it to validate the stolen credit card data so that they knew exactly which credit cards were still good to use. So again, I think we can definitely see the type of impact that this can have, not only on revenue, but also customer trust. Hopefully, at this point, I've convinced you that this is a significant issue that you should absolutely be paying attention to. And so hopefully at this point, you're asking, what can I be doing to help prevent these issues at my org? One of the first things that I think is really important to note is that business logic abuse really starts with development, right? And we need to make sure that these kinds of vulnerabilities are a priority in terms of educating developers and in terms of making sure that they have the right tools to detect them, so they can build applications where these conditions are not exploitable. However, as we know, building foolproof product, very difficult to do. And saying, well, we're just going to get it perfect the first time is never really enough. So we also need to have a mitigation plan, right? So this is about evaluating the existing tools that you already have in market or that you're already using internally to see if they might have business logic that is abusable. It's also very important when we're looking at this mitigation step to not only be able to detect that there's a business logic problem, but also be able to block it. Finally, this has to be a closed and iterable loop. When we look at testing, we want to be doing this kind of testing throughout the pipeline, giving those results back to developers, and testing both pre and post production, so that you can have this full loop of understanding what's out there now, how do we build it better, and how do we mitigate issues as they arise. I'm going to close out with just a couple quick slides on how Wallarm is addressing this for some of our customers today. And then we'll take a few minutes for Q&A. So when we look at customers broadly, and specifically, in this business logic abuse area, we see three main pain points where we can really step in and help. The first of those is a lack of API security posture management. So that's, companies that really don't understand what APIs do I have, or maybe even worse, companies that believe they understand exactly what their API landscape looks like, when in reality there are, thousands of APIs maybe in the system that they don't know about. Uh, but just understanding, okay, I have all of these APIs, that's not enough. You really need to be able to understand which of those APIs has access to sensitive information, because they need to be really on top of it with anything that has access to sensitive info, because that increases risk, right? And I need to understand which of my APIs are exposed. So it's really important to be taking both this, inside out inventory approach, but also an outside in, more, pen testing type approach of understanding where might I be exposed, and then being able to calibrate that against the information that you have, to understand which APIs are most vulnerable and which pose the most risk. The second area that we're helping a lot of customers address is their lack of runtime security when it comes to APIs. So this is all about that remediation mitigation piece. How do I fix the problems that are already in the system? How do I reduce the impact of issues that have arisen? And how do I block attacks in real time? I think this is a very important one, because there's a lot of tools out there that absolutely help you understand what's going on, maybe help you with that inventory, maybe even help you understand where you should put your efforts, but are not able to block API attacks. So it's really, an important piece of what Wallarm brings, in our toolbox. Finally, and I imagine this will probably resonate for everyone on the call, security teams, even dev teams, are often deeply understaffed, heavily under-resourced, and doing the best they can with very limited resources. And so this is one of the ways that APIs can go between the cracks. There are questions like, well, okay, whose job is it really to monitor API security tools? Well, they're, APIs are being developed. Is that with Eng? Okay, well, it's security, so that's with the security team. And maybe in a larger org, this threat detection piece, this incident response piece, maybe there's a SOC or a CERT that's there to do that. But in a smaller org, again, questions can come up around like, how do I identify, how do I investigate threats? And who's going to help create a report about what happened and help it not happen again? So this is a place where not only the tooling that Wallarm offers in terms of getting that clear picture, all of that reporting, but also automating so many of these tasks that are currently manual for a lot of folks out there, so that those under-resourced teams can really be focusing on what matters most. I'll wrap up with just a quick overview of the Wallarm solution. I think the things to call out here is this very broad coverage across types of APIs, et cetera, but also this really deep coverage of services and and those addressing those pain points that we talked about a moment ago. So we can see the ability to not just understand what's going on, but really block threats in real time. We're talking about the kinds of security testing that's really necessary to understand this. Doing all of that across a really broad deployment spectrum across cloud native, multi-cloud, hybrid, with deep integrations into your security ecosystems across SIM and SOAR, across all of the service management pieces. So really that ecosystem space being deeply integrated. And then finally, as I mentioned, helping our customers with support and with all of those other pieces to ensure that their team is making the absolute most of their resources. The last slide here just speaks to the white paper that we have on this. If you're looking for a step-by-step, each of these business logic top 10 and how WallArm addresses those, this is it's exactly what this resource does. So encourage you can just pop out a phone and grab that QR code, or go ahead and just type that into your browser. You can even just Google WallArm for OWASP Top 10. But it is a really cool resource that just goes threat by threat and really talks about how WallArm addresses each of them. With that, I am going to stop that screen share and look at the Q&A that have come in. Okay. Oh, we have a few. All right. The first question here, what kind of testing is needed to detect BLA? I think this is a really important question. We talked about stateless versus stateful. We talked about the different kinds of attacks. And so when we're thinking about detecting business logic abuse, you need testing that is going to look at behavior and workflows over time, not just look at single individual requests. Because when you look at individual requests, again, remember, this is software functioning as designed, if not as intended. So each of those individual requests looks fine. But when we look at the pattern across that session and say, oh, that's interesting that they're just trying every password under the sun, they're just trying every product ID on the site, that's when you can see that issue. So WallArm is really well suited for this because we are continuously observing real API traffic. Because of where we sit in your stack, we are able to correlate sequences across endpoints, across sessions, and detect when valid calls are then being used in abusive ways. So that gives you the ability to respond in real time, and we can do that, with we can block those as well. So you're not just getting a report on the issue after the fact. Hopefully that answers that question. Next up. All right, this was a little divisive. I'm not sure which side of which team this person sits on, but we've got how much of this comes down to bad application design versus missing security controls. So again, I don't know if this is a developer or a security practitioner asking this question. So we'll give, the answer is that it's really a mix of both. We saw on that slide where we talked about development mitigation and testing. Business logic abuse usually starts with design assumptions that are not enforced. But that becomes a very real risk when there are not security controls watching how the logic is used in production. So good design helps. Having a well-designed API or a well-designed tool really helps. But the watchword of cybersecurity is just that errors are inevitable. Creating a perfect product isn't the best security play. So it's important to have that kind of runtime visibility, the real-time understanding of what's going on, and the enforcement element to catch it. So even if well-designed logic falls victim to abuse, or a lot of these things also come up when maybe somebody leaves. So developer leaves a company and they leave behind a legacy of tools and things that they created that maybe aren't accessed in the same way by other folks. So, again, the best of intentions can still lead to issues that security enforcement is needed for. I think we probably have time for maybe one or two more questions. Okay, this overlaps, I think, a little bit with the first question that we answered, but worth addressing separately. If attackers are not breaking rules, what signals are you actually looking for to detect abuse? I think this is interesting because it comes down to signals that are behavioral rather than syntactic. So we're looking for things like abnormal sequences of API calls. We're looking for repeated or parallel use of actions that are meant to be one time only. Um, Looking for unexpected timing, looking for workflows that don't match how real users behave. I think one of the really cool things about the way the wall arm tool works is that we are building constantly an understanding of how the API, when used correctly, looks like what correct inline use looks like, right? And so then we can compare against that and correlate requests over time across endpoints, and then we can spot when valid usage is really abusive or is violating business intent, because we can compare it and say, no, that's not right. We know what this should look like, and that's not it. So I think it's a good question, and I think it comes. I talked a little bit earlier about the session blocking feature that Wallarm released recently, and one of the reasons that this came up is because we had this realization, have known, that IP blocking isn't working, right? There's all kinds of issues with that. Blocking individual requests is highly ineffective. And so the session blocking feature with Wallarm, which is part of the advanced API security package, is really about this. It's about understanding when individual, seemingly unconnected API calls are really actually part of a session that's abusive, and being able to block that whole session rather than just blocking one of those requests. All right, this one's another organizational question. How is business logic abuse different from fraud, and who usually owns fixing it? I'm paraphrasing a little bit here. Uh, so I think fraud, when we think about fraud, it's about intent and outcome. So business logic abuse is just about how a system can be misused, regardless of intent. Um, but the reality is that business logic abuse often sits somewhere between product and engineering and security, and as you mentioned, sometimes fraud or compliance teams. It's actually something that I've noticed a lot more lately. I'm going through Wallarm calls or talking to Wallarm customers. We are seeing an increased involvement of fraud teams, and I think that that's really positive because where we see organizations be most successful is organizations that are handling business logic abuse as a shared responsibility. So security is bringing enforcement and tools like Wallarm or others to help provide visibility and enforcement. Development is taking this very seriously from a building perspective, and fraud is taking an interest in how are these things being used. How are these things being used to create fraud? Because ultimately, when we think about the customer impacts, we talked about some of it, but a huge amount of it is revenue. When you have these kinds of abuses occurring, that equals lost revenue. And so I think a lot of fraud teams are really interested in this. Um, yeah, and of course, and engineering is then, they're helping to own the business rules themselves. So I think more people at the table is always the right answer there. Um, Beautiful. Well, looking at the time, that is what we have today. So thank you again very much to CyberEdge. Thank you so much to everybody attending. And if you did submit a question that we didn't get to on the call, please feel free. We will try to reach back out to folks. Um, but it's wonderful to chat with you all today. Take care. Bye.
All right, amazing. Thank you so much, Celeste, for the fabulous presentation and for going through the Q&A. We do have one last item to take care of before we finalize this presentation, and that is selecting our lucky gift card winner. So today's winner is Evan G. Congratulations, Evan. You will be hearing from me and only me within the next 24 hours with a link to select your gift card. Congratulations again. And with that, that concludes our webinar. On behalf of WallArm and Security Buzz, thank you so much for tuning in and take care.